Last time I had a look at rates of reactions, and I had a look at using a balance, very badly in fact, to look at how size affects, or particle size affects the rates of reactions. I'm going to do the same experiment today, but I'm going to do it two different ways. I'm going to collect the gas using a gas syringe, and I'm going to collect it over water, and we'll have a look at different ways of doing the same experiment, and we'll get some data and we'll see if we can plot it and make some sense of what we've got. So let's have a look at the experiment itself. What I have here is a gas syringe. The gas syringe, if I just disconnect it, here is an airtight syringe, and it holds here about 100 centimetre cube. That is 100, and it's got a little holder here, a little stop, so that if it goes too far it won't fall out. The ways that these are made, they're matched, and you might see here the numbers, and if we zoom in for a minute we should be able to see that it's got a set of numbers, 866 here and 866 there. So these are literally matched, so this makes an airtight joint. This is ground glass, and that exactly fits in there, and if we put some air in then this will move. So an airtight gas syringe. I've got a timer, and what I'm going to do is we're going to take some acid, and we're going to put some acid with some calcium carbonate. This is chalk, and I'm going to connect this up here so it makes an airtight seal, and we're ready to go. So what we need to do is to measure out some calcium carbonate, and we're going to react this with some acid. Last time I used acetic acid, which works quite well. This time I think we'll try hydrochloric acid, and we'll see if we can make that work a little bit better. So where am I going to start with? Well, we're going to get out some calcium carbonate, and I've got my mortar and pestle, and we're going to try and get out some of this. So let's take some out. I'm going to put this on a piece of paper, then I can put it back nicely. So let's just get a few bits of this out. And I want a reasonable lump. And when I'm looking for a reasonable lump, I'm looking for something that is going to be fairly sort of easy to get in there, and I don't want to go too big on the lumps. That would work, I suppose. Let's turn the balance on and we'll have a look and see what we've got. So if I put the weighing boat on, and then I can have a look at what this is, and that's about 4.8 grams, so that's 4.87. so I'm going to record my large lump, which is going to be 4.88. And I've just been passed some hydrochloric acid. We're going to take some small pieces, and this is going to measure up to 4.8 grams again. So let's take some small pieces, and that's why I've poured all this out, so I've got some fairly small pieces and I can get these. The good thing about chalk is that if I need to, I can actually just break bits off to make small lumps. That's sad. 4.75. Let's take a small piece out. Let's find a slightly larger small piece. That's 4.38. That's 5.4. That's too big. Let's see if I can break a bit off. 4.38. A bit heavy still. I've got a smaller piece here. That's 4.78. That's really going to be about as good as I'm going to get. So I'm going to that's sad, it broke really easily. Alright, we'll do that again. So we've got this that's 4.2. And that happens to be 4.2. Right, okay, so that'll do. Small is 4.23 and my large piece is 4.22. I'm not going to do much better than that. And then what we're also going to need is some really small stuff, and to do that I'm just going to scoop up some of this small stuff, this powder and small bits. What's that? Oh, 10 grams, easy enough. We'll now just break this up and make it a little bit finer. Don't really want all this other stuff here, but we'll see what we can do. So we'll now break this up into small pieces, really small. So this is sort of a powder, and I'm doing this by doing some twisting as I do this. And as I twist it, it grinds it. It's much better than sort of try hammering it. Hammering it doesn't work and basically just breaks things. So there we have some nice chalk powder. And I want 4.2 to 4.23, so we can go and I'm just tapping this, just trying to get out just a tiny amount. There we are, went up to 4.29. There we are, 4.22. So pretty accurate that's going to be. So we've got our 3 samples and we're going to try these out and we're going to see how well they work. Now I don't know how much gas that I'm actually going to produce on this. So we may find that we're not going to get this working too well, but we'll see. So I've got my amounts. What I'm going to do is we're going to record in time and the volume. So I'm going to record down here time, and if we go about every 5 seconds, I'll make a little chart up, 45, 50, 55, 60. And we'll run this for about 90 seconds. So I've got my large, I've got my small, and we've got the powder. Okay, so it appears that I'm now more or less ready to do my experiment. The only thing I now need is some acid in there, and the amount of acid I'm going to have is in fact going to be in excess. So I can measure this out in a measuring cylinder, but in fact, because it's going to be in excess, it's not going to matter too much. I have in fact got a measuring cylinder here, and I'm going to put in about 30 mils of acid. So we're ready more or less to start. I'm going to play around with acid. So I'm going to put my safety specs on. And we're ready to have a go. Right, I will get down so I can see this, and I've got 30 mils. So 30 mils of, in this case, 2 molar hydrochloric acid. It's a rather large measuring cylinder, but it works for what I want. Now, a slight change to the advertised procedure. I'm just going to wash my hands, because I've got a small amount of acid on my hands, and if you immediately wash it off, it doesn't matter. Right, we're ready to go. We've got the timer, I've got my amounts, we're going to put the acid in there, we've got it in there, I've got this already on. What I want to do now is to put this in there, and I'm going to start the timer, and we're going to watch the readings on there, and I'm going to call them out as we go. So as we start, we know our first value here for 0 is at 0, and we're going to have to be pretty quick on doing this, and I'm going to get Paul to press the start button on the timer when we're ready to go. 3, 2, 1, go. And I've already got quite a lot out, and whoa, there we are. I've stopped that, and I knew that was going to be fast, and I did stop it. It's still going. So in less than 5 seconds we've got 100 centimetre cubed. I knew it was going to be that fast, because when we've done it before, it's been that quick. So let's try this experiment again. This time I'm going to do it with the same amount of acid, but we're going to do it with these larger lumps, and I'm predicting this is going to be perhaps a little slower. One of the reasons I did this with acetic acid last time was to make the reaction a little bit slower. So if I reset that, we're now ready to start again. So I've got my bung ready to go in. I've got my pieces of chalk ready, and we're going to start the timer. You can't quite see that timer. There we are. You can see the timer now. Ready? 3, 2, 1, go. 5, we've got 23. 10, I've got 51. 15, I've got 73. 20, I've got 95. And that is that experiment over. It really was quite quick trying to do that. Now what I'm just going to do is I'm just going to wash this one up very quickly. And you can hear noises off as I just wash up. Right, so now we're going to do the third of the experiments. So let's reset. Right, stop, reset, good. And we're ready to have a go. I want 30 centimetre cubed of acid. We're just going for 30 because we know that is excess for what we want. And we've got now the large lump to go in, so we'll time this one as well. I'm making sure the bung's in the right place, so here we go. 3, 2, 1, go. And we had a little slight error, we'll do it again. 3, 2, 1, go. Right, so at 5 seconds I've got 18. 10 seconds I've got 31. 15 seconds I've got 41. 20 seconds I've got about 52. 25 seconds we had 61. 30 seconds I've got 71. These are going quite nicely. 35 seconds I've got 81. 40 seconds I've got about 91. And at 50 seconds we're bust. And I can stop this reaction. And what I'm just going to do is I'm just going to pour the acid away. So let's have a look at this experiment very quickly and we can see what we've got. So what I'm going to do is let's try and plot the results. So I'll take my safety specs off and we'll go over and plot out the results. Here are my results. They weren't very much, they went very quickly. Just grabbing some graph paper and we'll see what we've got. I had a choice when I started this experiment, and the choice that I had was to either make the experiment work at the powder and then we can hardly see the large, or I can try it at the small and gamble that the powder is going to still be very fast and we can see the large, which is what I've done. So let's see if we can now draw this graph out of the results. So we've got the time, which is going to go at the bottom, and we'll have our graph of, let's just put some of these in so I can put some values in a 0. I'm only going up to about 80. The reason is not really necessary there. I suppose I should have gone down a few more. Well, 100, 95, 90, 85, 80, and then that's going to give me 75, 70, 65, 60, 55, 50, 45, 40, and then we'll go 35, 30, 25, 20, 15, 10, 5 and 0. Yeah, right, so I have sorted my line out. I didn't plan it really well, and going across we've got our time, and looking at our times we've got to only go up to 40 seconds. Let's do our powder first, and in less than 5 seconds it had reached 100. Our second one, we start 0, 5 seconds we've got 27, which is going to be about there. In 10 seconds we hit 51. In 15 seconds we hit 73, and in 20 seconds we hit 95. And we can see that is actually quite a remarkably straight line. Then for our last set of data, let's just have a look and see what we've got. So at 5 seconds we had 18, 10 seconds we got 31, 15 we got 41, at 20 seconds we got about 52, 25 seconds about 61, 71, 81, 91, and then bust. And if we look at this graph, it's not quite a straight line. But it's got a slight curve at the bottom. Let's label what we've got. We've got the powder, we've got the small, and we've got the large. These are centimetre cubed of CO2 produced, and we've also got, looking down here, a measurement of time, measured of course in seconds. So there's our first experiment, and this is measuring using a gas syringe. Many schools don't allow you to use gas syringes because they say, oh, it's too expensive, and the teacher does it. When I was at school, I used to use gas syringes, and we were just told not to break them. If you did, then we used to hang people or something similar to that. Seemed quite reasonable. Nobody broke them. So let's see if we can do the same experiment again, but I'm going to use a different setup. So let's go over and have a look. Now, in this setup, what we're going to have a look at is collecting over water. So I'm going to take my gas syringe out of the way and move it out of the way. And I'm simply going to do that because that's an expensive piece of kit. And what we're going to do is we're going to collect over water. And what I've got here is a trough which we're going to fill with water, and then I knew I was going to forget something. We're going to collect the gas. Now I can do it like this, but I'm going to find it easier not to. I've got a piece of tubing, and what we can do is we can put something over there which is called a beehive shelf, and I didn't get one. And if I just connect this piece up, if all is well set up and organised, then the height of that and the height of that are correct. And I forgot the beehive shelf. Fortunately for me, one arrived, and here is a beehive shelf. So cool because it's got this little hole here that fits over that tube, and what I can do is make sure that when I look down here that I can see this piece of glass tubing sticking up, and I've got it so this is going to be hard against this piece, that's going to be there, and what we're going to do is we're going to take this measuring cylinder, which has got acid in it at the moment, but I'm not worried about that, and what I'm going to do is turn this upside down, and I'm going to place this over the hole, and then we can lower this So this is my basic setup. The only difference is we're going to want to fill this all with water, so that when we start to do this experiment we're going to collect over water, and it's not going to reach, so I'm just going to move everything. Don't want it set up quite ready just yet because we have a little problem, and you've got a problem that I need you to solve for me. So there's that, and what we're going to do is going to fill this with some water. Oh, just stand it on there. We're lucky that what we've got here is a tap that we can then use to fill this without having to move it. And Paul's going to fill this about 3/4 full. And that'll do. Right. I'll just move the cables for the camera. Got that set back up. We've got the tubing set up. I'm going to put this beehive shelf in the place. I should have rinsed that before. It's a little bit dirty. And now I've got a problem. What I've got to do is I've got to fill this up with water, tip it upside down and put it in. And Paul's just going to wash that out and give it to me, and I'm going to show you the easy way that we can actually set this up. So Paul's going to fill this right to the brim with water. And when I mean to the brim, I really do mean that. And there we are, we've got it literally filled right to the top. Now how to try and get it in there? Well, there are various ways people do, and they put their hand over it and they try all sorts of things. It doesn't work normally quite as well as you expect. But then there is a really easy way of doing it, and this involves just a piece of cling film. My hardest job with the cling film will be to get a piece off, and that will magically appear for me in a moment. Right, so we're ready really with this experiment, and what we're going to do is we're going to try and look at this. Now I've cheated and I've got out some 3 small pieces of calcium carbonate, and I've got 1 large piece. If you're very clever, you can recognise they're the same pieces we had last time, and I'm not after getting exact results here, I'm after a technique. Right, so let's put this over the top, and I've got a bubble in there. Don't particularly want the bubble in there. I've now got rid of the bubble, and now if I turn this upside down and put it into the water, I can take the piece of cling film off, and apart from the fact it's wet, we can reuse this. And now I can pick this up and put this on top of our beehive shelf, and I can clamp it into place. I'm going to turn it round so that you can see. I managed to get a bit of air in there, that wasn't very helpful. That's all ready to go. We're going to use the small pieces, and I'm going to add the acid to that. Fortunately, I have another 100 ml measuring cylinder, and I'm going to measure out my 30 centimetre cubes of acid. This one is much harder to read. This is my oldest measuring cylinder, and I don't really wish to tell you how old it is. Let's just put it this way. It's slightly older than I am. Now, I failed. I didn't put my safety specs on. Right. We've got the acid ready to go. I've got my stop clock ready to go. So I'm going to put the stop clock down this side so that you'll be able to see it in a minute. We've got our acid in there. Let's just put the acid in there. And let's measure how we go. We've done this experiment once before, so this time we're really having a look at a different technique. 3, 2, 1, go. And we can see as we go along, I'm going to have to start at 10 seconds. That's going to give us 21. 15, it's going to be about 36. 20, that was about 51. 25, 62. 30 was 78. 35, 92. And 40, we're bust, and we're going along collecting all our carbon dioxide. And that is the end of this experiment. This way seems to work quite nicely. It's quite an accurate way of trying to measure what we've got. We should get the same results with this, and that's why I didn't bother to basically record everything, because I've done the experiment already, and this is just trying to show you an alternative way of making it work. So I've collected carbon dioxide here. I could prove that's carbon dioxide with a test for lime water. Of course, I tried that last time and it didn't work, so not to be defeated, I'm going to do it again. I've got some lime water, and what I'm going to do is I'm going to try this into a boiling tube. I've got my clean straw out, and let's get out the boiling tube, and into this boiling tube I'm going to put some lime water. After last week I did repeat this experiment and it worked. I haven't tried it since, so it may work or it may not. Lime water in here, And what I'm going to do is just blow in here very gently. I'm going to do it over this water just in case. And thank goodness this time chemistry didn't let me down, and the lime water does go cloudy. What I would need to do, however, to show that's lime water and carbon dioxide, would be to try and be a bit more crafty in doing this experiment. And I'm going to try it and see if I can have a bit of luck. I'm going to take my cling film, and what we're going to do is, I'm just going to undo this, and I'm going to just put the cling film over the top just to try and keep the gas in there, and move bits and pieces out of the way. So I can do the experiment. I've got then this with some carbon dioxide in there. I'm just going to take some lime water, and I'm just going to put some lime water in there quickly. And if I shake it up, it's gone cloudy, proving that I actually did manage to make carbon dioxide. I got away with that one because I could have actually left the lid off and it still would have worked, because carbon dioxide is heavier than air. What have we done? We've looked at 3 different experiments. We've looked at the production of carbon dioxide from calcium carbonate. So we took calcium carbonate plus some acid, and we used vinegar. This time we used hydrochloric acid, and acid plus a carbonate gives us a salt. This time it was calcium chloride plus water plus carbon dioxide. We measured the amount of carbon dioxide collected either using a balance, and that didn't work. Of course, I tried it after the experiment and it worked beautifully, and that gives us a graph that is decreasing. We can collect using a syringe, and that system of trying to collect it with a syringe, it works and is probably the most accurate that we've got. The third way was collecting over water. Now, the only problem that we have with collecting over water is that sometimes some gases may dissolve in water. They nearly all do, but not necessarily very much and very quickly. So as long as we're reasonably quick, we're okay. And here we've got our flask. The flask connected to a piece of tubing When I started doing chemistry as a boy, then in my class we would have to actually make these pieces of glass tubing before we actually did the experiment. Nowadays they don't tend to let you do that. And this is a graduated cylinder, and we've got water in there, and you can see how we filled that up. And both of these experiments should have given us the same results. Measuring against here volume against time, and we're looking at the powder having the fastest rate of reaction because it's got the largest surface area, the small pieces being in the middle, and the large pieces being the slowest. And that gives us an idea of the rate of the reaction. We can measure the gradient here, and the gradient equals the rate of the reaction. There are more ways of trying to measure rates of reactions. This is just using a gas. If we've got colour change, then we can use other systems. And a very popular way is with an experiment with hydrochloric acid and sodium thiosulfate and watching an X disappear. We'll have a look at that one next time, but what we will do to try and improve it is we will find an improved way of trying to do this experiment. So until next time on GCSE chemistry topic by topic, if you liked it, subscribe, give us a thumbs up, and stay safe, and I'll see you next time. Take care. Bye bye.